Welcome back, everyone, to the Lighting Controls Podcast here live in Boston at the Boston Lights Show presented by DLF New England. Today we have here, well, right now we have Ray. I'm getting into my old podcast. But Ray, you're from JDRF. Really appreciate you sponsoring this. So this live stream right here is sponsored by JDRF. It's a really great platform. Really provides an excellent resource for those groups that have challenges with the startup and commissioning of their systems. So do you mind just giving us a little breakdown on what JDRF is for people who might not be familiar with it?
Absolutely. Thanks for having me, gentlemen.
Absolutely.
So JDRF has developed the world's first self-commissioned luminaire level lighting control system. We call it autonomy lighting, and it is really the first autonomous lighting control system in the history of lighting controls. What makes this innovation possible are really three groundbreaking innovations. First, we've equipped every single one of our devices with a near-infrared system. And that near-infrared system essentially scans the built environment and develops a type of 3D map in real time. So the system is able to contextualize its surroundings. Sensors know which other sensors are in the same room, and they even know where they are with respect to their lighting arrangement. Okay. The second piece is every product has onboard machine learning. Okay, so we collect data, we train in the cloud. The result of that training is a model that's deployed into each and embedded into each device. The machine learning is there to process daylight levels and motion patterns so that the system can understand things like which light is by the window and which one is not. We have a large deployment with a massive retailer where our system is able to understand which light is above an aisle and which one is not. Onboard machine learning makes that possible. And then the third piece is we've decentralized all of the application logic so that we don't have external control boxes or any hardware of any kind, and we don't need an internet connection for the system to run.
Right.
We've taken the smarts that generally lives inside each and every control box, and we've embedded it into each and every one of our products. That not only lowers the cost of the system and eliminates a major point in the design, but it also drastically increases the reliability of the system. There are no single points of failure. If any product goes down, the failure is limited to that product. It never propagates to a system-wide issue. So we can peel the onion and dive into all of those. I know that was a bit of a long answer.
No, totally. But it really is incredible because I feel like every single day now I get somebody who comes up to me saying, oh, AI is going to do all of that for you eventually. And it's like, yeah, it can. I mean, the way JDRF employs its logic is really unique because of the fact that it has this self-awareness. It has this identity going, oh, yeah, you're by the window, you're over the aisle, and that is really unique. It really is an incredible resource.
Indeed. And this is the result of about 5 years of R&D. In a former life, I was a co-founder of a smart lighting company, so I'm very well aware of the challenges with large-scale deployment. And the tedious and the mundane repetitive work that has to happen simply to create a zone, right? And in the context of digital lighting, where every light fixture is a network address, deploying lighting systems has really become akin to deploying large-scale networks. And we can train folks within the industry to do that, but many building managers don't want that to be part of their job. So we decided to really swing for the fences and take on a big problem and see if we can pull together a system that's affordable, that completely automates that commissioning process. And you guys all know what's involved in that. There are a lot of pieces to commissioning. So there were a lot of distinct R&D projects that all had to come together to make this possible.
The idea of an autonomous self-commissioning system is fascinating. But I'm curious about, it's a small aspect, but the second you mentioned it, how do you deal with daylighting and daylight harvesting and actually setting a set point if the system is autonomous?
Yeah, so a few steps, right? So the first step is lights have to figure out who's in the same room, right? Because you don't want your daylight zone to span multiple rooms, right? So the infrared piece helps with that.
Right.
The second part here is we figure out the total power consumption of that room. So our sensor works with D4I compliant drivers. It could be anybody's D4I compliant driver. But the nice thing about a D4I compliant driver is that it has a built-in power meter. So when a sensor is able to measure the power that's consumed by its luminaire, and every sensor knows which other luminaires are in the same room, they can add that up and figure out whether their total power consumption is above a threshold, like 300 watts as specified in the ASHRAE standard, right? So if they're above 300 watts, they go to the next step, and they basically say, okay, which one of us is by the window? And it took me 20 years of working in the lighting industry to realize that the lights by the window get more ambient light than the ones further into the space, right? And, you know, you kind of smack your forehead, but no other lighting company, to my knowledge, has that ability, right? Now, it's easy to say. In practice, it's actually quite difficult to figure out which lights are by the window because we all know the photodynamic effects in a room. You can have glass boards and reflective surfaces or a low afternoon sun. And, you know, there are all kinds of weather phenomena and environmental phenomena where the third row in can actually read more ambient light than the one right by the window.
Yes. Yeah.
But with the right, with the long enough observation period, with the right statistical model, with the right training, you can actually get really accurate at figuring out which lights are by the window. So now you can create primary zones, secondary zones, and it all happens automatically. The beauty of this isn't just the one-time setup. It's the ability for the system to adapt to change. And change happens when you go from a base building deployment to a tenant fit out, tenant fit out phase A to phase B. Oh, wrong fixture, time to replace.
Right.
Maybe our high-end trim has taken us above or below that 300-watt threshold. Who maintains all of that, right? And so that's why a lot of customers just disable daylight harvesting.
Right.
But with our case, you get it out of the box for free, and it's adaptive, so you never have to worry about maintaining it.
That's awesome.
No, I think that that's a really incredible resource. And so I have, you know, some commissioning providers screaming in my ear right now going, well, what if the reflective surface on the task that you're trying to measure changes from a bright white surface to an incredibly dark absorptive surface?
So what in the ideal case, you want to get as much sensor coverage in a room so that you're not biasing your readings based on an outlier, right? Like one small reflective area. So the way daylight harvesting should be done is take readings from every sensor. That's the most dense measurement network that you have available to you, right? If you've got 10 lights in a room, the best you're going to be able to do is to take 10 distinct measurements. Right. If you want 20 measurements, you're going to have to put some more lights in that room, right? So our constraint is you have a maximum of, let's say in this case, 10 possible measurement points. Use them all, right? Sure. So our system will take an average reading across all 10, okay? That average reading will be fed into the feedback loop in order to achieve a set point, right? Set point is automatically calibrated to meet specific building codes and guidelines. It can be changed through the mobile app if you wanted to. But essentially what we have is the most robust implementation of daylight harvesting done autonomously, right? There's no lead device that runs the control loop.
Right. Yep.
There's no one particular device that takes a measurement that's more important than the other measurements. You have a room, you want uniformity in that room, you take measurements from all devices in the room, you average it, you run your control loop. That's the most robust way, and I think the control folks would appreciate and agree with
totally.
That, right?
That's fascinating. So when you take like your average school or office building, and you've got 10 classrooms, a hallway, right, just a small section, how long with an autonomous system? How long is the actual sort of commissioning process for an area of a building like that?
So in the worst case, if you have a large open area and you need to really get smart about how the daylight zones are going to be configured, it could take up to a full 24-hour cycle. And so we say to folks, worst case, 24 hours. In practice, it can be as little as 30 minutes or maybe up to a couple of hours.
Okay. Awesome.
No, that's great. Well, Ray, really appreciate you coming on the show, talking about JDRF. Yeah. When it comes to lighting controls, what are you seeing on the horizon? What is JDRF planning to bring through the pipeline, or things that you wish you saw in the lighting controls world?
Yeah, so I think we look at every single area of value that lighting controls can provide, and our goal is to automate that step.
Sure.
Right? So we look at everything from the visualization interfaces to collecting measurement and verification data, energy data, fault data, space utilization is something that we think certain customers want, not at any price. It's got to be maybe something that's just a free feature. In general, we have entered the world of AI-enabled systems. You can leave it to your imagination to think, what can you do if you had powerful AI living in every light fixture and what are the manual tasks that are normally done. And I think if you look at history, it's really hard to find a case where a technology that is manual, more expensive, and error prone has outcompeted a technology that is automated,
Right.
cheaper, and easier for all stakeholders to use, right? So we believe that we're ushering in that future, and it's an exciting time for us.
Well, really appreciate you coming on the show. Thank you all for watching the live stream here, live at Boston Lights. If you're checking it out live, you should come down and actually see the show, because there's a lot of great stuff, including JDRF has a booth here. What's the number?
515.
515.
Awesome.
Check them out.
Yeah.